Hey guys, so today we are going to discuss Visor curves. So how these curves can be generated under the control of points. That is, certain points are used in order to generate these control points. So now let us see that what are the approximate tangents that we can use in order to draw the Visor curve. That is, tangents are used and they are drawn by using the control points to generate the curve. That is, suppose we have 2 points over here, then tangents are drawn to it in order to draw the in order to draw the curve, which is known as the Visor curve, and these points are known as the control points. So now let us see that how the Visor curve can be represented mathematically. Now we can represent the Visor curve by this equation, that is sigma k from 0 to n pi bi to the power n into t. Now pi is the set of control points, that is these points as we discussed before. These are the pi represents the control points and bint represents the Bernstein polynomial. Now what is Bernstein polynomial? Bernstein polynomial is given by this equation, that is bint is equal to ni of into 1 minus t to the power n minus I to t to the power I. Now over here n is equal to the polynomial degree, and over here over here the value of I is also the known as the index. That is, n is the polynomial degree, I is the index, and we have t as the variable. So these are the three things which is given by n, I and t, and this is known as the Bernstein polynomial. And this is how the Visor curve is represented mathematically. Now this thing, that is ni by I, that it can be written as ni factorial upon I factorial into n minus I factorial. That is how you write this thing. Now let us see what type of Visor curves we have. That is the simplest Visor curve that exists is a straight line, or we can say a linear line. That is, we suppose we have 2 points p0 and p1, p0 and p1, and these two are the control points. And this over here, the control points is joined by two lines, one line, and this is known as the straight line, and this is the simplest Visor curve that we can have. Now let us discuss what other type of Visor curves we have. Suppose now we have the second form, that is the quadratic Visor curve. Now quadratic Visor curve is represented by three control points, that is p1, p2 and p0. That is, from p0 to p1 we will draw a line, or we can say the tangents. So this is the quadratic Visor curve. And thirdly, we have cubic Visor curve. That is cubic Visor curve. And a cubic Visor curve is represented by four control points. That is, we have four control points in this, that is p0, p1, p2 and p3. So these are the four control points, and we will join p0 to p3. So this is how you represent different types of Visor curves, and so on. We can have furthermore Visor curves, but we will only be discussing these three, as these three are the main curves that we will be using. So now you must have noticed something, that here we have a simplest, that is a straight line of degree 1, and here the we have two control points, and a straight line is of degree 1, and the control points represented by CP are 2. So we can say that if the control points are x, then x minus 1 is the degree of a polynomial. Suppose if CP is equal to x, then the degree of a polynomial will be equal to x minus 1, that is 1 less than the value of x. That is, we have a degree of this polynomial line as 1 and the control points are 2. Now similarly over here you will see that we have three control points, that is 3CP, and whereas the degree is quadratic, and by quadratic we know that the degree of polynomial that is DOP is 2. So we can write that DOP is equal to the number of control points minus 1. That is, the degree of a polynomial is equal to the number of control points minus 1. And similarly over here you will notice that we have four control points, that is P1, P2, P3 and P3 starting from P0. And over here we have a cubic curve, and we know that by cubic we mean that the degree of the polynomial will be equal to 3 and the number of control points over here is equal to 4. So we can write that DOP, or the degree of polynomial, is equal to control points minus 1. So this is a very important property of Visor curve and you should remember it. Now let us summarize the properties of Visor curve that we have discussed and we will be discussing now. That is, let us come to property 1. Let us write properties. And we will be discussing certain properties that are very important for Visor curve. That is, the first one is that they generally follow the shape of the central polygon, which consists of segments joining the control points. Now let me write it for you. That is, they generally follow the shape of the central polygon, or we can say of the control polygon, which consists, of segments joining the control points. That is, suppose we have 3 points. Suppose that is, we have a quadratic Visor curve, and this is P0, P1 and P2. So joining these 2 points, that is, this is the polygon that we are forming. So the polygon that we have formed over here, this is they are followed the control of the poly, that is, the Visor curve will be this. This will be the Visor curve. That is, we can say by they we mean the Visor curve. Visor curve generally follow the shape of the control polygon, which consists of segments joining the control points. So the control points are P0, P1 and P2. So now let us come to the second property. That is, in property 2 we have that they always pass through the first and the last control points. They always pass through the first and the last control points. Now what do we understand by this? Let me first clear this out. Now let us understand in detail that what we mean by this statement or the property. Suppose again we have a quadratic cubic polynomial. Now let us take a cubic polynomial in which we have the control points as P0, P1, P2 and P3. Now you must have noticed above that we drew our line or the curve from P0 to P3, and over here we drew it from P0 to P2, and here we had only 2 points, so the line will obviously be from P0 to P1 only. But the thing to notice over here is that we always start from the initial point and we always end at the last point. That is, by they we mean the Visor curve. Visor curve always pass through the first point and the last control points. That is, they always pass through the first control point and the last control point. So this is our second property, which is very simple. Now let us come to property number 3. Now in property number 3 is that they are contained inside the convex hull of their defining control points. That is, they are contained inside the convex hull. They are contained inside the convex hull of the defining control points. Now what we mean by this is, suppose we again have a cubic polynomial or a cubic Visor curve, that is P0, P1, P2 and P3. Now suppose that we draw this line again, or the tangent again, or we can say the Visor curve, that is from P0 to P3, satisfying property number 2. Now here we mean that the Visor curve, which will be inside these control points, is contained inside the convex hull. That the convex hull means that this line that we have drawn, that is this part. The Visor curve will always be contained inside this convex hull of the control points. That is, by the Visor curve will never be going outside the curve like this and coming back. It will never happen like that. Our Bezier curve will always be contained inside the control points that we have. That is inside these 4 points, and this is true for every degree. That is, suppose if we have a quadratic, then it will always lie inside this convex hull of these 3 points. That is 3 control points. They will never fall outside it. So this is what is meant by that they are contained inside the convex hull. Now let us come to the fourth point. Let us discuss the fourth point. That is the Bezier curves exhibit global control. That is, global control is there. That is, it means that moving a point alters the shape of the whole curve. So what we mean by this is, let us discuss. Suppose we have a cubic, or a quadratic. Let us take a quadratic Bezier curve. So this is point P naught, P1, P2 and P3. P2, sorry, P0, P1, P2 and now we will draw the Bezier curve from P0 to P1. Now here we will see that a point, if the point is changed, suppose if I change P1, if the position of P1 is changed, let me take P1 over here. That is, now P1 is over here and P0 is here and P2 is here. Now our Bezier curve will look something like this. That is, its shape will be altered by the movement of any point. And suppose if I move P0, then the value of this curve or the shape of this curve will be altered. That is, if you change any such point, that is, if you change P1, P0 or P2, then the shape of the Bezier curve will be affected by it. So this is what is called global control. That is, if you change the position of the point, then the curve or the shape of the Bezier curve will change. Now let us come to the final property. That is property number 5. Now the degree of a polynomial, this property number 5 we have already discussed. That is, the degree of a polynomial defining the curve segment is 1 less than the number of the defining polygon control points. So what we mean by this is that the degree of a polynomial, I am writing in short form, that is, let me write it again. Degree of polynomial will always be equal to the number of control points minus 1. Suppose if there are 4 control points, then the degree of the polynomial will be 1 less than that. That is, we have 4 control points. Then the DOP or the degree of the polynomial will be 3. That is, we will have a cubic Bezier curve that we have already discussed. That is, we saw over here that the degree of a polynomial will be 1 less than the number of the control points, as which is evident from these two points, as we can see that there are 3 points, whereas the degree of the Bezier curve is quadratic, which is 2. So these are the 5 important points, 5 important properties of Bezier curve that you should know. That is, let us just give a summary again. That is, first they follow the shape of the control polygon. That is, the shape of the control polygon is formed. That is, from P0 to P1 you go, and the Bezier curve will also follow that same line which you have drawn from P0 to P2. Now second point is that they always pass through the first and the last control points. That is, what we mean by that is that they will always pass through P0 and they will then always go to the last control point, that is P3 over here. That is from P0 to P3. Now let us just see the third point. That is, they are contained inside the convex hull of the defining control points. That is, suppose there are 4 control points over here, P0, P1, P2 and P3. So the control hull which is formed by these 3 points, that is this part which I am highlighting. This point, the convex hull will never lie, the Bezier curve will never lie outside this convex hull. That is, it will never go over here. They will only lie inside the polygon formed by these control points. Now the fourth property is that they have global control, and by global control we mean that whenever a point is changed, irrespective which point is changed, then the curve shape or the Bezier curve shape will change, no matter which point you position you change. Suppose if P0 is P1 is changed, and from the initial position of P1, then the shape of the Bezier curve will also change. And the last property was the most important property, that the degree of polynomial of Bezier curve will be equal to the number of control points minus 1. That is, we discussed earlier that the degree of a polynomial will be 1 less than the control point, as we have seen in the 3 examples discussed. That is, over here the degree of polynomial will be 1, as we have 2 control points, and here the degree of polynomial will be 2, as we had 3 control points, and here the degree of polynomial will be 3 as we had 4 control points. Now guys, let us, if you were able to understand the concepts discussed in this chapter in this video, then just write wow in the comment section, and it would be great to know that you were able to understand it. And guys, this is the first video that I have made in dark mode. My all the initial videos are in light mode. So if you like this mode better than the light mode, just write dark in the comment section, and I would know that you want me to make more videos in the dark mode. And otherwise, if you want me to make videos in the light mode, just write light in the comment section. And do not forget to subscribe our channel, as it helps us to create more videos in order for you to understand the concept better and clearer. So guys, these are the important properties that we discussed for Visor curves and the how it can be mathematically represented. So guys, this is it for this video. Do not forget to subscribe. Now see you in the next one.